All right, we're going to take a look at the triangle congruency, side, 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 angle, side, angle, angle, side, and hypotenuse leg. So here we have the first one, side, side, side. That one is fairly evident in that we have given three sides corresponding to another triangle with the same measurements, the same three sides. Those two triangles are therefore congruent. That means this triangle right here is congruent to this one right here. Now I don't have my writing pad working, so I'm using a mouse, so my writing is going to be limited this time around. So let's take a look at this example. Given AB is congruent to BC, alrighty, so this side right here is congruent to this side right here. I'm going to put my tick marks there. And BD is the median. Median is just another word for splitting something right down the middle. You have the median of the road, you learn median in middle school, so on. So BD is the median of side AC. That means this right here and this right here are congruent. I'm putting two tick marks right here for these two. Well, we need a third side, and we have what is called a gimme, freebie, whatever you want to label it, but we use the reflexive property that BD is congruent to DB or itself. So I'm going to put three tick marks right here, and I have these three sides, side, 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 is congruent to side, side, side. So using the side, side, side postulate, we now have ABD congruent to CBD. And so we can write triangle I can't write with the mouse. BD is congruent. See how terrible that is? Triangle, upside down triangle, CB, I give up. Can't write with the mouse. Well, anyway, this triangle is congruent with that one. Moving on. Side, angle, side. Now, one thing you need to learn about this is that the letter order is extremely important. It is vital. It defines the entire definition. You have to have a side, next to it is an angle, and next to it is a side. And that's exactly what we have here. We have a side, we have an angle, and we have a side. You can't go around the loop like that. That angle is inclusive inside these two sides. It contains it. This is the included part. So let's take a look at an example. This is what I call a bow tie problem, and something always pops in my head when I see these. Yes, you're right, the vertical angles. But let's see what's given. C is the midpoint of BF. Well, here's BF. C is the midpoint, so that means this side and that side are congruent. And our second thing that's given is AC is equal to, it should be congruent, to CE. AC is congruent to CE. So we have two sides congruent. We can't assume these sides are congruent. We have no proof. We can't wish it so. There's nothing right now that we can tell that those two sides are congruent. We'd have to prove it later. But we do know we have another freebie. We have a gimme right here. This angle is vertical angles. That means BCA is congruent to ECF. Now look what I have. I have side, angle, side. Side, angle, side. We got to make sure we correspond the right sides to the right sides. So we just have BCA is congruent to FCE. I'm not going to write that out. All right. Next example. Angle, side, angle. And again, the wording, the letters have to match the picture perfectly. We have angle, side, angle. Angle, side, angle. That means these two triangles are congruent. Here's our example. Let's take a look at what's given. Angle BAC is congruent or equal to, if we had the measures, DEC. So BAC, I'm going to draw it right here, and DEC are congruent. All right. BD bisects AE. So BD bisects AE. That means these sides right here are congruent. Alrighty, I need something else. Yes, another bow tie problem. That means that we have vertical angles. And you notice how I'm making this picture here match angle, side, angle. It has to match. And I have my angle, side, angle. Here's an angle. Boom. There's a side. And there's another angle. Angle, side, angle. And we have angle, side, angle. Therefore, these two triangles are congruent. Angle, angle, side. Same theme. It's got to be angle, angle, side. You can't go any other way in the order. So here we have an example. We are given C as the midpoint. right here, a BE. Guess what? Those two are congruent. AB is parallel to DE. So I'm going to write my little parallel line things here. And when I see parallel, one of the first things that enters my mind and needs to enter your mind is transversals. And what kind of angle pairs and relationships a transversal makes with two parallel lines. Very often in these type of problems in this chapter, it's going to be alternate interior angles. Given parallel lines, alternate interior angles are congruent. That's one of your previous theorems. So look what we have here. We have a side and an angle. Well, we have a bow tie problem, so I'm going to have these two angles congruent right here. So I have angle, angle, well actually this angle first, this angle second, and that side. Angle, angle, side. Angle, angle, side. Alright, so we can prove these two triangles are congruent. Hypotenuse leg. A lot of people miss this one because when they see a right triangle, they immediately put down hypotenuse leg with no thought whatsoever. That would be a no-no. So if you see a right triangle problem, you need to have a hypotenuse and a leg. And the reason that works is because we're just basically using the Pythagorean theorem. A squared plus b squared equals c squared. Given 2, we can always find the third. Well, we're given 2, we can find the third. And if these two are the same as these two, guess what? This has to equal to the same thing. So let's take a look at an example. AD is perpendicular to CB. Perpendicular means right angle, so I'm going to draw that in there. And remember, your picture has to match your problem. Draw right angles on both sides because you're dealing with two separate triangles. Now we know that there's a perpendicular that forms a right angle. That's definition. That's kind of like a gimme. And AC is congruent to AB. There's AC and AB. Well, by definition, these are my hypotenuses. All I need is a leg. Reflexive property right here. AD is congruent to itself. So I now have hypotenuse, leg, hypotenuse, leg. These are two separate triangles. That's two separate legs for each triangle. They just happen to be living together right on top of each other. So I have hypotenuse, leg. All right, so that's just an overview of the triangle congruencies. I want to end with where I grabbed these. I looked down around the web. I was going to make my own, but I got lazy on a nice Sunday morning. I got to go to church here in a few minutes. Examples taken from Math Warehouse. Interactive examples. These are very good because looky here. I'm going to go to this site. You're not going to be able to see it all on this thing though. Nope, you're not going to be able to see it. But anyway, you go to this website. You can actually move the triangles around, and you can move and do the interactive examples. I strongly suggest that website. Alrighty, 8 minutes, a little bit longer. That's why it's not called a mini lesson. I will see you this week.